I said Channel 4, the refurbishment of the Channel 4 facade in London. So it was a project from the 90s, a high-tech facade with a lot of glass, some point fixing, suspended glass facade, double curved cable net, and a really optimized system, structural. But there was some damages in the glass, which was really high risk, and there were also some fixings out of positions in the cable net, which was also a high risk. And this combination led to the situation that it was not safe to walk around there. And that was the starting point for the refurbishment. What we saw is, of course, during the 80s and 90s, they developed a concept of structural glazing and point-supported glass system in a whole series of projects. And this was the last one of a series. So this was the pinnacle of this era. And they optimized everything. So they did a lot of testing. There were some really smart engineers working on this one. And we saw, okay, the safety concept is something which they appreciated in the 90s, but nowadays, fully toughened single sheet of glass, suspended 9 panels from top to bottom, with hardly any post-breakage behavior. So we saw, okay, there are some damages in the facade, in the glass. We see some deviations in the cable net. We want to improve the robustness, but everything what we can do is adding also a little bit of the weight, but everything was optimized. And that was the biggest challenge from that part of view to introduce more robustness. On the other side, there was the disassembly. Normally we do not disassemble too many facades, but in this case was, okay, we have glass which is damaged around the rotulas. Already 2 panes broke. Who can tell us that none of the other panes will break when we are working somewhere on the facade? And we saw also these fixings in the cable net which were not in position, and these were essential for the connection between the vertical and the horizontal cables. And in this connection, there were the connections which we saw, quite tricky. If they slide out a little bit, we had top head pins which made the connection, and they were out like 4 millimeter. And from calculations we saw, if it is out like 5 millimeter, this could cause a sudden release of energy because of the disconnection between the horizontal and the vertical cable. So we had on one side the cable net, where we said, oh, if we touch this one, we could have a sudden release of energy. And on the other side, we had just 1 meter away from this, with the connection of articulated bars, we have the glass facade, which was damaged, and already a few were broken. So we thought, oh, if this cable net goes, the whole facade goes down. And that was the starting point for disassembly, is how to disassemble this in a safe way. So we know from this facade, it's suspended. The glass is the first line of the load line. The second load part is the structural sealant in between the glass columns, but we came up with a third load part just for the disassembly, that each glass panel was separately supported from the steel crown at the top. And on the cable net, all the clamps, we applied, especially made for this project, special clamps to keep all the fixings in positions, so we were sure that we didn't have the sudden release of energy. And then we defined a sequence of releasing a little bit of the pre-tension, then taking off the panels, and then releasing all the energy from the cable net, so taking off all the pre-stress. And with this, we were able to upgrade the connections, get everything in position again. We adjusted a few elements, minimum some minimum changes. But with this, we were able to get everything aligned again, and then we started with the assembly after a lot of testing. But for us, it was really new to use with such a tight tolerances in all the milling elements. Because normally we have tolerances, well, we are quite tight already if we have 1 or 2 millimeters, but now we were talking about 20 micrometers, and we wanted to use old and new materials, and it should fit perfectly. So that was a challenge for us here, and a certain roughness of the surface of the cable clamps, which was also interesting to understand. So for this, we also did some testing in Swiss for the cable clamps and with pre-stress, and how does it respond to higher forces. And we saw that the whole cable clamp was following the threads of the cable while sliding. So that was interesting for us to see. So in other you go for skiing, you see a lot of cables, so there's a lot of information available in other and not specific to facade industry. So we pick up some new information nowadays on from different groups. Another thing which was interesting here for us, we saw the countersunk connection in the glass, which led to really high stresses around the glass hole, but also in the long term, we saw the shelling around the glass hole. So we said, okay, we try to avoid this, so we introduced this Hilt injection. It's not something in particular which we used as a new element, because we did it before for glass ring connections, but it was new to have a whole chain of glass with this Hilt injected elements. So the rotula with the Hilti around it in the glass hole. So for this, in a laminated glass pane, we did also a lot of testing, and we did it in France together with SADEF to understand, okay, what is the behavior in this composition for this facade. Other thing was to understand how this double curved cable net, how does it work? How is it pre-stressed? Because what you see in the cable net, you have to elongate the cable, and in this particular case we stressed the vertical cables, and then the horizontal cables were also pre-stressed, respond from one to the other, and if you pre-stress on the left side a little bit more, there's a response on the right side of the facade also, and it's a balance of force versus form. So are we spot on with the forces, or are we spot on with the shape? And we saw that it was in certain points where the horizontal and vertical cable met in these clamps, these locations was up to 50 millimeter off in the original one. And we had long talks about this. Well, do we want to improve this so that we get it in a better shape, or we keep it the same? And we decided to stay as close as possible to the original shape, because you don't know exactly what's gonna happen if you come with an other distribution of the pre-stress in the cables. So these kind of things, it's not what we normally do, because normally we define something in the computer and say, this is what we're gonna do. And now we had a lot of information on materials, on shape, on pre-stresses, which we had to incorporate in our line of thoughts. So all kind of things came together again. So I cannot pick one single element there now. Well, a few things. First thing, open some old books. For this project in particular, I had also a book about structural glass of Peter Rice, which really gave a good background information of the line of thoughts, where they thought of for designing these kind of things. And the second thing, enjoy the puzzle. never stop puzzling, because that is the most fun there is. So it's in the beginning, you don't know what you have to do, but puzzle until you have something which you're proud of. That's the whole idea, if you ask me.